Hey guys, I want to show you a nice little bit of information about how I was able to just yesterday create a weather cover system so that I can know whether the player is covered from the weather effects or not. So for example, if you're under a cover like this, I want the game to show that the player is under cover. And also change and update according to the weather system that also changes angles. Like for example, snow, ash and rain will change its angle according to the wind speed. So I wanted that to pick up the correct angle from the weather direction. And it actually turned out to be fairly easy, surprisingly. I thought it might have been difficult, but basically I went to a website and just downloaded the formula. So it is a bit of math. So basically it's a right hand triangle sort of system. B, if that's the ground, and C is the angle from the sky that the weather is coming down at. I want to measure this one here, alpha. So there's B there. C is the angle from the sky coming down, and that alpha angle is what I want to work out. So I can theoretically rotate a 3D mesh from the player's position towards the weather effect to get the to match the angle of the weather effect accurately to determine whether you're undercover or not. There may be a more complex way to do that, but basically I just changed the rotation, something like this, from the player. It's just a simple 3D mesh. Child noded to something like that, which just I just code that, change the position to match the player, and all I want to do is rotate that to at the right angle to match the weather angle in the sky, to then get the position of it, to run a line from the player to that position and to determine does it collide with anything at all or does it not. So that was how I went about it, and it seems to be working pretty good. So going back to the formula, so C is the angle direction coming down from the sky. B is the ground, so that's alpha. So for example, A and B, you got 1 and 2. You can show the calculation steps. So in other words, it's just the square root of x squared plus y squared in this case, because my weather effect is always coming from the same direction. They all do at the moment, so that makes it a little bit easier. So for example, the weather effects, they have gravity force. So there's your x, movement on the horizontal. Here's the y, the speed at which it comes down. The z is always 0 for me because I'm always making it come from the same direction. So I'm only looking at x and y, and it's the combination of those two to work out the angle, which is what used here. So you punch that in, you get a number, and then you'll need to inverse sine or arc sine. I've used what I know, which is the one that's always going to happen, which is A, the vertical. There's always a vertical, there's not always a horizontal sometimes. So A and C, so the math for that one is this one. That one right there. Angle alpha equals inverse sine A over C. So that's what I did. So for example, under this one, every 300 milliseconds, I just run a bit of code. I just determined that, yeah, what weather effects I want to check, and this is the code here. So I'm getting the current weather x and weather y, x and y of the weather effect, which is sometimes adjusted by the wind and sometimes not. Sometimes it's fixed. So I pick that up, x square root x times x plus y times y, asyn, and then you just divide the y over the, it's called the hypotenuse, or the long side of the triangle, and multiply that by a set number. That's an approximate to give you the degrees, because it gives you radians by default, so you multiply it by approximately 57.3 to give you the degrees. That's close enough for what I need. So once I have the angle, then I just get down to this thing here, reposition that according to match the player, and rotate it upwards by that amount. So you can see it's actually a negative angle for me. So the higher it is, the more negative, up to negative 90 max, between 0 and negative 90. Yeah, so that actually works quite well. I'll show you that now in the game. Okay, so there's my little, I've just put a yellow colour on it just so you can see it for the demo, but later on I'll just make it transparent, you won't be able to see anything. So what it does, once the weather effect comes into play, this is only the warning stage at the moment, but once the weather effect actually starts coming in, that will then activate the movement of this yellow box here, and which is the origin is matched to the player's position and just rotated according to the angle as calculated, as I showed you. So that should start working any second. There it is. So, and I've got it, see how there? As I move, it moves, and it matches the angle of the weather effect, so that's quite good. And you can, obstruction, I've got a little shield indicator just to let me know that it's obstructed or you're undercover. Yeah, or not. And if you're out of cover, then you can take damage. Got a little radiation thing over here as well, so that's building up over time. It's pretty funny. Yeah. Now obviously the weather particles are going through the roof. They go through everything. So that's my next project, is to, when you're undercover, or say for example you're inside a cave or something like that, you got to move the weather effect so it doesn't, the particles don't come through the roof, basically. There's no collision with weather particles at the moment. I don't know if Nico ever watches this video, but if you do, Nico, I really need weather particle collision detection, such that it can be yeah, doesn't go through walls, basically. Yeah. Okay, let's get rid of that one. Okay, so that's a little bit radiated there. A bit funny, isn't it? I probably should change the intensity of that radiation effect on the picture over time, because you know, you're not really that radiated too much just yet. Alright, we've got snow. See how the angle now of this yellow box has changed according to the snow angle, which is adjusted according to the wind. Yeah, so as the wind dies down, that'll adjust itself as well, as it's doing that right now. Actually, it's slowly going to go up until it's closer to 90 degrees above the player as the wind dies down. Yeah, so that all works quite well actually. Yeah, so that was the thing I was going for. So no matter weather effect, I can theoretically I can determine when the player's in and out of cover, which is good. And that works for any 3D mesh in the whole level, including like rocks and whatever. Doesn't matter. If it finds anything, it'll know whether it's being obstructed, the weather particles, or not. Yeah, so it works pretty good. So that was an extremely important part of my game I just added. It only took like a day or two actually. It was pretty good actually, not too bad. See if we can get any meteorites. Here we go, meteorites 40%. So Same thing. It's a warning system at the beginning. Okay, let's just speed that up a bit. Okay, so I'm undercover. Oops, takes some damage. And the guy goes red too, so it's funny. Yeah. So that's an instantaneous damage. You can see the player health takes damage instantaneously. That way. Yeah. Yeah, so that works quite well. It was a fairly simple, really, on relatively speaking. Not highly complex code, but just a bit of maths. You've got to know how to run a triangle. That's about it. So I'm not covered here. Yeah. Boom. Yeah. Okay. So yeah, that works pretty good. So that's just how I did it. I'll just show you the code a bit more. Yeah. So once I've got the angle and I've adjusted the rotation of the thing that I'm detecting the weather angle from, it's just simply get collision point of world with line. You just run a line from the player to the position of the object that I've rotated to see whether it interacts with anything, and if it doesn't, then it's not, you're not undercover. But if it does, then you are undercover. So yeah, so it's pretty relatively straightforward. Yeah, so anyone that uses JavaScript in CopyCube, it's not that bad. It's actually pretty easy. Yeah, so I thought you might like that. Cheers.